Let's begin coding out our Sieve of Eratosthenes algorithm by defining it as a function. Which takes in a number, n, as a parameter. The first thing we want to do is make an array that goes from 0 to n, and make each element of that array the value true. We will do this with a for loop. We will first define our array by saying variable primes equals an empty array. We will then define our for loop by saying variable I equals 0, while I is less than or equal to the number passed in, increase I by 1 on every iteration. Inside of our for loop, we will simply set primes at position I equal to the value true. Great. Now we have an array from 0 to n, and we have initially marked every value as true, which signifies that each number is prime. The next step is to simply mark the values of 0 and 1 as false, because we know that they are never prime numbers. So we will say primes at index 0 equals false, and primes at index 1 equals false. Great. The next step is to mark the multiples of each index as false as we loop through our primes array. This will be done with a nested for loop. Our outer for loop is the one that will take us from index 2 in the array, which is where we will start since we already marked index 0 and 1 as false, all the way up to the square root of the number we passed into our function. So we will write for variable I equals 2, while I is less than or equal to math.square root of our number, increase I by 1 on every iteration. Great, that is our outer loop. Now our inner loop is where we will handle marking the multiples of each number we pass as false. So we will say for variable j equals 2, while j times I is less than num, increase j by 1 on every iteration. We say while j times I is less than our number right here, because I times j is each multiple of the current index, or I. For example, let's say that our outer loop is on its second iteration, so our variable I is currently equal to 3. Our j variable starts at 2, so our first multiple is 6. On the next iteration, I will still be 3, and j will also be 3. So our multiple will be 9. On the next iteration, I will still be 3, and j will be 4 now. So our next multiple is 12. We want to keep increasing our multiples as long as it is less than the number passed into our function. When the multiple is larger than the number passed into our function, we don't care about it. So our inner for loop stops and our outer one moves on to the next iteration. Inside of our inner loop, we will simply mark each multiple as false. As we just saw, each multiple of the current index is represented by I times j. So we will simply write primes at position I times j equals false. And just like that, we have marked all of the non-prime numbers in our primes array as false. Pretty cool, huh? Now, all we need to do is return the numbers that are prime and still marked as true. We will do this with another separate for loop down here. We will first define a results array to place all of our prime numbers in. So we will say var result equals an empty array. Then we will write for variable I equals 0, while I is less than primes.length, do I plus plus. And inside of here, we will simply write if primes at position I. If this is true, then we want to do result.push I, which is a prime number. And finally, down here, we want to return our result array. And that is it. That is our Sieve of Eratosthenes algorithm. Let's test it to make sure that it works in the next video.